In this example, we want to find the coordinates of the turning points of y is 1 minus x over x squared plus 3, and we want to determine the nature. So here we have a quotient. U is 1 minus x, and v is x squared plus 3. That means du dx is equal to minus 1, and dv dx is equal to 2x. We know the quotient rule is that dy dx is v du dx, take away u dv dx, all over v squared. So dy dx is equal to v times du dx, which is minus x squared plus 3, take away u dv dx, which is 2x times 1 minus x, all over v squared, which is x squared plus 3, all squared. So dy dx is equal to minus x squared take 3, take away 2x plus 2x squared, all over x squared plus 3 squared. Tidying this up, we get dy dx is x squared minus 2x minus 3 over x squared plus 3, all squared. If we want turning points, we need dy dx to be equal to 0. That means the numerator needs to be 0, so x squared minus 2x minus 3 is equal to 0. This quadratic factorizes, so we get x and x, minus 3 and plus 1, so x equals 3, or x is minus 1. If x is equal to 3, then y is going to be 1 take away 3, that's minus 2, over 9 plus 3, which is 12, minus 2 over 12, is minus 1/6. If x is minus 1, this becomes 1 plus 1, which is 2, over 1 plus 3, which is 4, so 2 over 4 is a half. To determine the nature of the turning points, we need to have d2y dx squared. Once again, we have a quotient. U is x squared minus 2x minus 3, and v is x squared plus 3 squared. Du dx then is 2x minus 2, and dv dx, and we need the chain rule here, is twice x squared plus 3 to the power 1 times the differential of inside, which is 2x, giving us 4x, x squared plus 3. Following the quotient rule again, d2y dx squared is v du dx, so that's 2x minus 2 into x squared plus 3 squared, take away u dv dx, so that's 4x, x squared plus 3 times x squared minus 2x minus 3 all over x squared plus 3 to the power 4. We can do a small amount of cancelling. We get 2x minus 2, x squared plus 3. Take away 4x into x squared minus 2x minus 3, all over x squared plus 3 cubed. So I've cancelled one of these off with one of those and this one. Let's consider when x is 3. This will be positive, positive, and this will be 0. So the top is positive, the bottom is positive, and so d2y dx squared is positive. That means we have a minimum at 3 minus 1/6. Now let's consider the situation when x is minus 1. We would get minus 2 take away 2, that's minus 4 times 4, take away minus 4. If x is minus 1, this is 1, plus 2, take away 3, so that's 0. All divided by 1 plus 3, which is 4, cubed. So we've got a negative over a positive, giving us a negative. So d2y dx squared is negative, and therefore we have a max at minus 1/2.